Welcome to online lecture series in organic chemistry, and we are discussing the organometallic compounds. In earlier video we have seen the preparation of organometallic compounds by oxidative addition method or direct reaction of metal. So next method is transmetalation reaction or metal-metal exchange reaction. So in transmetalation reaction, more active metal displaces the less reactive metal from its compound. In this method, actually, the organomercury compound, it is used as a reagent because mercury carbon bond is weak. And here most important thing is the more reactive metal displaces the less reactive metal. Which are the more reactive metals? Metals which are higher in electrochemical series. These are the more reactive metals like sodium, magnesium, zinc, aluminium, calcium, gallium, etc. And less reactive metals are mercury itself, thallium, lead, bismuth. These are the less reactive metals. So generally in this method, one organometallic compound, especially organometallic compound of mercury, thallium, lead and bismuth, it is converted into other organometallic compound like organometallic compound of sodium, magnesium, aluminium, zinc, calcium, etc. For example, consider the general reaction Rm, that is one organometallic compound of mercury. For example, this M is mercury. When treated with M dash is an active metal like sodium, magnesium, etc. Then this active metal M dash displaces less active metal, that is M, and there is a formation of Rm dash, that is organometallic compound of more active metal. For example, when organometallic compound of mercury, that is dimethyl mercury, when mixed with sodium, there is a formation of methyl sodium, that is organometallic compound of sodium plus mercury. So this mercury, it can be reused. Another example, when dimethyl mercury, when mixed with zinc, here zinc is more reactive than mercury. Zinc displaces mercury and there is a formation of dimethyl zinc plus mercury. Similarly, when dimethyl mercury is mixed with aluminium, here aluminium is more reactive than mercury. Aluminium displaces mercury and we get trimethyl aluminium and there is a formation of mercury. Similarly, dimethyl mercury when mixed with gallium, gallium is more reactive than mercury, then there is a displacement of mercury by gallium, we get trimethyl gallium plus mercury. And when dimethyl mercury is mixed with tin, tin displaces mercury and we get tetramethyl tin and mercury. So mercury is collected at the bottom of reaction mixture, which is reused again. So this is about the transmetallation reaction. More active metal displaces the less active metal, and one organometallic compound, especially organometallic compound of mercury, thallium, lead and bismuth, it is converted into other organometallic compound of more reactive metal. Now third method for the preparation of organometallic compound, it is metathesis, also called as carbanion halide exchange reaction. In this metathesis reaction, exchange takes place between carbanion with halide. Carbanion is a carbon bearing negative charge. So this carbanion gets exchanged with halide ion. It is called as metathesis. And the most common reagent used for this metathesis reaction is alkyls of more active metals like lithium, magnesium, aluminum, etc., and halides of group 13, 14 and 15 elements. The most common reagents for metathesis are alkyls of lithium, magnesium, aluminum and halides of group 13, 14 and 15 elements. Group 13 element is a boron family, 14 element it is a carbon family, and 15 element it is nitrogen family. Again, here in this method, in metathesis reaction, alkyl group migrates from less electronegative element or metal to more electronegative element. This is the most important thing. Alkyl group migrates from less electronegative element to more electronegative element, and we get organometallic compound of more electronegative element. For example, Mr, this is the organometallic compound, when treated with the halide EX, halide of group 13, 14 or 15 element, then there is a formation of Mx, that is metal halide plus organometallic compound. Okay, so organometallic compound of group 13, 14 and 15 element. For example, when methyl lithium, it is mixed with silicon tetrachloride or tetrachlorosilane, then here there is a, actually lithium has a electronegativity, it is equal to 0.98 and electronegativity of silicon is 1.9, and therefore methyl group or this carbanion exchange with silicon. Silicon is more electronegative atom. As I said, alkyl group migrates from less electronegative element to more electronegative element. So this alkyl group, methyl group, migrates from less electronegative lithium to more electronegative silicon, and therefore we get lithium chloride plus tetramethyl silicon. This is the organometallic compound. Other example, when alkyl lithium is treated with magnesium halide, then we get lithium halide plus organometallic compound RMgX. This is the Grignard reagent. Magnesium is attached to alkyl group and halogen. So here lithium is less electronegative, magnesium is more electronegative, and therefore R group migrates from lithium to magnesium. Basically, actually magnesium, it is not group 13, 14, 15 element, but this reaction is also exceptionally possible for group second elements as well, that is magnesium. Another general reaction is when Mr, that is the one organometallic compound of metal M, when mixed with zinc halide, then this R group migrates from M to Zn. This M is less electronegative than Zn. So R group migrates from M, that is less electronegative element, to more electronegative element, and we get organometallic compound of Zn. Similarly, when Mr, that is organometallic compound of metal M, which is less electronegative than cadmium, when mixed with cadmium chloride, then R group migrates from M to cadmium. Cadmium must be, or cadmium is more here more electronegative than M. this metal M, and we get dialkyl cadmium. This is the organometallic compound. Similarly, when alkyl lithium is treated with aluminum chloride, then alkyl group migrates from lithium to aluminum. Aluminum is more electronegative than lithium, and we get organometallic compound of aluminum. So this is what is metathesis. The next reaction is metallation or metal hydrogen exchange reaction. So in these reactions, organometallic compounds are prepared by the replacement of hydrogen of hydrocarbon with a suitable metal ion or suitable metal. In metal hydrogen exchange reaction or metallation reaction, organometallic compound is prepared by replacement of hydrogen atom of hydrocarbon like cyclopentadiene or any other hydrocarbon with suitable metal. For example, RH, this is the hydrocarbon. When mixed with organometallic compound, here M is metal, R is alkyl group, so there is a formation of Rm, that is new organometallic compound, and here actually this metal displaces this hydrogen, and this metal joins with this R, we get Rm, and this hydrogen, displaced hydrogen, joins with R dash, and there is a formation of other hydrocarbon. We'll take example. So this is cyclopentadiene. When treated with methyl lithium, then one of the hydrogen of cyclopentadiene, it is displaced by lithium, and there is a formation of cyclopentadiene lithium. This is organometallic compound, plus there is a formation of methane. Similarly, when cyclopentadiene is treated with N-butyl sodium, then sodium displaces one of the hydrogen of this cyclopentadiene, and there is a formation of organometallic compound of sodium, that is sodium cyclopentadiene plus butane. Similarly, when cyclopentadiene is treated with sodium alkoxide, then sodium displaces hydrogen, one of the hydrogen of this C5H6 cyclopentadiene. We get sodium cyclopentadiene as organometallic compound, and displaced hydrogen joins with this alkoxy group, and we get alcohol, ROH. Similarly, C6H5 thrice CH, this is triphenyl methane. When treated with ethyl lithium, then lithium displaces this hydrogen of triphenyl methane, and there is a formation of organometallic compound of lithium. At the same time, the C2H5 group joins with this displaced hydrogen, or this is carbanion, it joins with hydrogen, and there is a formation of ethane. So in metallation reaction, as I said, there is a replacement or displacement of hydrogen of hydrocarbon with suitable metal, and there is a formation of organometallic compound.